I'll just start since we have a tight schedule. So welcome everyone to the 8th International Workshop on Declarative Decision and Hybrid Approaches to Processes. We have a nice program for you today. So a little bit about the workshop. Let me just get through it. So the workshop has been running for some time now, and we have always been interested in more decision-based approaches or rule-based approaches and hybrid approaches to BPM, with a focus on modeling, but also other phases of the BPM lifecycle. So identification of processes, process discovery, process analysis, process redesign, implementation, and monitoring. And we welcome papers from all these areas, as long as they have this either decision-based, rule-based, or hybrid taste to them somehow. So the workshop started in 2013 as DEMIMAP, where the focus was more on investigating knowledge-based processes, knowledge-intensive processes, with focus on variability, flexibility, and a large focus on more decision processes and process decisions. And then from 2017, we brought in more the declarative and hybrid approaches as well, and started focusing also more on what is the rules of processes and trying to model these with declarative notations. The program for today, well, we have the welcome and opening right now. Then we will have a keynote by Andrea Butterin. Then there will be a short coffee break of 20 minutes until 11. Afterwards, we have two talks. Then we have another coffee break, and then we have two more paper presentations. And we will close around close to 1 o'clock, 20 to 1, or 10 to 1. So it is my pleasure to introduce Andrea now. He will be telling us a little bit about his work on online process mining and on understandability of process models. This talk called "A Robot May Not Injure a Human Being: Improving Declarative Processes." Andrea has a PhD from Bologna and Padua University, and currently he is an associate professor at DTU. It's my pleasure to work with him. And if I remember correctly, he also recently joined the steering committee of the EA task force on process mining. So it's my pleasure to now let him take over and give his talk. Can you share your screen, Andrea, or should
I? No, I should be able to share. I have to stop. You should stop first.
Yeah, exactly. Sorry. Good.
Good. Do you see my screen?
Yeah.
Yes. Good. Okay. So welcome everyone, and thank you for joining here. As Thijs mentioned, today I would like to talk about improving business processes using robots, and in particular how I think we should use the robots to improve the processes. So a bit of background. I think Thijs already mentioned I did my PhD in Italy, then a couple of postdocs again in Italy and in Austria, and since a few years I'm in Denmark, and I investigated several topics within the BPM, but mostly around process mining technology or process mining research. And of course, I'm super lucky to work with great guys. So I think it's a quite nice area, and I'm very happy to be here at BPM and at this workshop because it's very nice. So let's start with the very what I think is the very end goal of the whole conference that we are attending today. So why do we manage business processes? Well, I think in all our minds we have some answers to this question, and we manage business processes for different reasons. For example, for documentation purposes, because we want to visualize functions and processes. We want to measure the success or the value which is provided by performing these processes. We manage business process to analyze different options, different scenarios, and understand how we can identify optimal configurations. we manage business processes to control their deployment, the implementation of them. But ultimately, we manage business processes to improve them. And these sort of improving the business processes, this notion is intrinsic in almost all definitions. And for example, in the fundamentals of business process management, they mentioned the BPM life cycle. And that is exactly one example of how to improve business processes in a structured way. So I would say that the ultimate reason for managing business processes is to improve them. So now the question is, I'm not sure why there are these lines on the presentation, but never mind. So the ultimate question, I think, is how should we improve business processes? And of course, we can identify many techniques, for example, the BPM life cycle. But according to my experience, we can identify two steps. The first is being able to understand what is going on, what is happening. We need to first understand where we are standing. And then, starting from this understanding, we can redesign the current process in order to optimize their performance or to improve some optimization function. And these, of course, will lead to better processes, which in turn means a happier life, right now, hopefully. Better life because maybe we can improve the processes so that we have to do less frequently boring tasks, or better life because we can achieve our goals in less time and we can spend more time in whatever we want. So hopefully we want to achieve this happier life as soon as possible, right? So in order to do these two steps, we have different options. Option one is essentially implementing the first step, the understanding what is going on step, with human beings and with pen and paper. That's how it has been done, for example, by having interviews with stakeholders and by interacting with them. Then we can give this process to other human beings. And these human beings, again, with pen and paper, they can just work to identify what are the critical points and how the process can be redrawn and improved. This most likely will lead to a better processes and probably to a happier life, but not really soon, because this process is very time consuming, so we will be a bit older by then, and that's something we don't want. There's also the problem that having humans involved on this process is a very biased approach. So for example, in understanding what is going on, we all know that whenever we're interviewing stakeholders for eliciting the processes, quite often we may get different processes from different persons, though they're talking about the same activities. So the first option is something that we typically don't want. Option number two is to use robots. So we can have robots, and here with robots, I mean algorithms, I mean automated systems, right? So we can perform the first activity with robots. So we can have algorithm to automatically mine the process data. And then we can do also the redesign process with robots. And most likely robots will identify human beings as the problem in the process, and they will probably just kick us out of the equation. So that's also something that most likely we don't want. So my point here is that probably we need to find a proper balance between the two options and find, let's say, the optimal spot so that we can indeed exploit the robots to improve the processes in a good way, in a proper way. But let's first focus on the first step, because the first step, understanding what is going on, I think is where, I mean, from a chronological point of view, is of course the first challenge that we need to face. And it's probably the biggest challenge as well. So we need to understand what is going on. And this, I think, this goal, this task can be decomposed into two sub-goals. The first is to, we want to focus on what is going on right now. So we want to focus on the current situation. We want to focus on what is happening right now. And that's, of course, because if we want to improve the process, we need to improve with respect to the current situation and not to the situation, for example, that was recorded in an event log, which is referring to last year or to the previous 5 years, right? Because otherwise we could end up in optimizing with respect to something that is not relevant anymore. Yeah. And to tackle this first challenge, we have this technology, which is being investigated, called online process mining, which is which aims exactly at understanding or doing process mining in real time on online data. And then the second, let's say, component of this understanding what is going on is that it is important to understand the outcomes of process mining. So by just producing a process model, for example, as a result of the online process mining step, that's most likely not enough, because we want to make sure that the persons that are using these models are really able to understand them, so that, for example, they can use these models to train robots, so that essentially the labels used for the optimization, for the machine learning of the robots are robust and reliable, let's say. So somehow I think that, and by the way, right now there is a big discussion on explainable AI, and that's of course a very important step. We all want robots that are not only telling us that how we should improve the process, but also how we should do, why we should do it. This is essentially the idea of explainable AI. But of course, in order to have explainable AI, we need first to be able to understand the models that are used to communicate with the AI. So I believe that understandability of the models, for example, in the context of this workshop, of course, we're talking about process models. So having a deep understanding of the process models is somehow a prerequisite to the explainability of them that the AI might be able to provide us. This step, of course, is particularly relevant in the case of declarative and hybrid languages. We all know that declarative languages are a bit more challenging from an understandability point of view. They're a bit more, they require a bit more of cognitive effort to be understood because of many reasons, but yeah, that's the point. In particular, if we look at the declarative languages, here in Denmark, they're being adopted quite a lot. In particular, I've in the context of my research, I've been collaborating with DCR Solution, which is a company that developed the DCR language, and they are currently deploying these. They're deploying process models defined using DCR in many public and private institutes. So the point is that these making sure that people have a good understanding, and therefore people can optimize and can use machine learning to optimize this process, is becoming a key challenge, an important challenge. So after this introduction and motivation, I would like to present you a couple of approaches. One, to how we tackle the online process mining problem in the context of declarative processes, and another brief part where I will talk a bit about the understandability of declarative processes. And then I will wrap up and conclude the presentation. So let's start by investigating the online process mining aspect. So I'm assuming that most of us are familiar with process mining, but let me recap what is the input for process mining, for offline process mining. Typically, we have an event log which is given as input, and in an event log, we're able to group all our executions by case ID. So essentially, we know when an execution started, we know when a process instance started, and we know when a process instance finished. This is not the case anymore when we're dealing with an event stream, because in an event stream, we are essentially just observing the events as they're coming through. So we can represent an event stream as in the top line of this figure as a sequence of events, and each event is referring to a certain process instance. So each event has a certain case ID, and each event is referring to a specific activity. Of course, we can also have different attributes that might be represented as vectors, for example. But the first problem is how to unfold, how to disentangle the different process instances that are being executed from this single sequence. Once this is done, then we can isolate each process instance, but we do not have a clear notion of when the process instance started and when the process instance is going to finish, because the observation time might be just in between these executions. So you probably see already that the problem is a bit more challenging compared to the typical offline setting. So then the stream process discovery, or the process discovery problem, is essentially the problem of, let's say, having a stream miner instance, switching on this process miner, and then continuously receiving these events that are being generated. And the goal is to mine these events to identify a certain process model. But this process model is not static. This process model is being updated as new events are coming in. So essentially, the process model is giving a representation of as we said at the very beginning, of the current situation, of what is going on. So if some constraints are not relevant anymore, these constraints should be removed. And if some new constraints are being observed, those should appear in the new process representation. So for this specific work, we actually started from standard declare, which is a set of templates based on linear temporal logic. Example of constraints are response and precedence between pairs of activities, indicating, for example, in the case of the response, that if activity A occurs, then B must occur afterwards. But in the context of this work, we actually extended this declared language into MP declare, which stands for multi-perspective declare. And in this case, not only we can express constraints referring to the activities, to the control flow, but we can also have first-order logic conditions. So, for example, in the case of response between two activities, we can add a first-order logic condition that must hold in order to have the whole constraint valid. This allows us, for example, to express constraints like if A occurs with some specific process attributes, then B must occur afterwards. Or we can also express conditions that are referring to the time properties of A and B. For example, if A occurs, B must occur afterwards within a certain time range. So we use this MP-declare language for our online process mining, online discovery. And essentially, as I sketched already, when we talk about online algorithms, essentially we have some computational challenges that we need to tackle. Specifically, we have bounded memory constraints, so we cannot store all the events as they're being observed, because in principle the event stream can be infinite. So we need to keep a summary of the event stream and to be able to cope with that. But we also have time complexity constraints, like that for each event, we have just a constant time available to process it. So that leads us to some approximations in the model. And in particular, we derived a discovery algorithm starting from the algorithm called lossy counting, which is an algorithm well known in the stream mining community for counting, for doing approximated counting of variables in a stream. And by adapting this lossy counting algorithm, we were able to keep only the most recent and the most reliable rules into the model. To extend the models with the conditions, we actually use Höfting trees, which are also well-known data structures in the stream mining community. And essentially, Höfting trees allows us to generate decision trees, and we adapted these decision trees to decorate our conditions. To do that, let's take, for example, the response between A and B. The first step is labeling the data. So we identified all the fulfillments of our response A-B, and we identified all the attributes for A and B in cases where there was indeed a fulfillment. Then we identified all the variables associated to A and B as well in the case of violations, and then the cases when the rule was not activated. And then by running these Höfting trees, we were able, and using essentially the fulfillment or the violation as a label, we were able to identify the data conditions leading to each label. And then by manipulating, by adapting these labels, we were able to elicit the actual conditions. So as you see, however, to express these models, we used somehow decision trees or Höfting trees and declare models. So of course the problem is how should we ensure that these models are understandable? And as we know, we can have different models associated so we can characterize modeling languages according to different perspectives. And the point is that quite often it is not possible to use a single language to capture the richness of a process. Even in the example that I mentioned before, we had declared language and decision trees. So it's quite often it is the case that we have these hybrid constructs in order to capture the complexity of a process. And in particular, whenever we talk about hybrid constructs, we can distinguish between hybrid languages or hybrid artifacts. Hybrid languages can be again divided into languages that are using a hierarchical structure, taking different notations, or mixed structure. And in the case of hybrid process artifacts, essentially we're talking about the same representation, the same process which is conveyed using different representations. So this is somehow taking us to the second part, to the second question, which is the understandability issue for the current situation. And in our context, we can, in this research, we actually investigated different notions of understandability. For example, a possible question we can ask is, how do end users are engaging with the different artifacts that are used to express a process model? Or what strategies are followed when trying to make sense out of a process description? So we can measure the understandability using different approaches. We can use, for example, subjective measurements like think aloud studies. We can use performance measures. So, for example, we can give to a bunch of subjects a set of questions and identify which are in which situations the questions were answered the best. We can use behavioral measurements, or we can use physiological measurements. So we tried some of these questions, and I want to give you sorry, I was just reading the chat. I have only a few minutes left, apparently. So I want to give you some hints on how we use that. So first of all, to express our processes, we use this DEC2H, which is a hybrid representation for processes, and actually it's what is called a hybrid artifact, meaning that we have the same process which is conveyed using different representations. So we have a process representation, a graphical representation on the top left. On the right, we have a simulation tool that allows us to execute and understand which executions of the process are actually valid. And at the bottom left, we have textual description representation for snippets or parts of the process. And to understand, to investigate the understandability of these artifacts, we use eye tracking technology, which allows us to track how the users are engaging, how the users are looking at the different parts of the screen while answering some questions. And the first step is to divide the visual stimulus into what are called areas of interest. And these are, for example, 3 areas of interest. So the graph, the simulation, and the text. And by using eye trackers, you can essentially track the sequence of steps that are followed by the gaze of a person while answering a question. In reality, of course, we have way more areas of interest, and here they are depicted. So what is important, though, is that what we could do is to transform this eye tracking data into data that can be analyzed using process mining. And we were able to identify what are called attention maps, which are essentially process maps describing how the subjects were interacting with the process from a cognitive point of view, from an attention point of view. And we could derive some conclusions. For example, we could identify different maps according to different subjects' profiles. So, for example, domain experts were doing many more interactions between the graphical representation and the textual description, as opposed to the IT specialists who were using just a bit the simulation, but not that much the textual description. And of course, this helped us to answer the understandability question concerning how the users are actually engaging with the different artifacts of the process representation. Another set of maps that we could derive, another, let's say, set of maps we could derive was based on which task the user they were facing. So essentially, how were the different, so which understandability question, which sense-making question were the user tackling, was also affecting which artifacts the different subjects were using. So this is hinting towards different understandability levels based on the purpose of the, based on the task. So based on what is the final goal of the sense-making process. We also did some think aloud, and of course we could identify some pros and cons, some benefits and challenges for each representation. And for example, the graphical representation gives a good overview, but of course its semantics is a bit more hard, as opposed, for example, to this simulation tool, which is very good for testing and validating assumptions. But of course, it's a bit inefficient because you need to plug in all the different traces in order to be able to make some, to have a deep understanding of the whole process. In the end, we recently also tried this personal construct psychology, which is essentially a technique that allows to essentially construct or by asking specific type of questions, we could identify these similarities and differences that led to grouping similarities for specific properties, which in turn can be defined, can be used to derive properties, abstract properties, leading to more understandable process models or leading to less understandable process models. I will not get into that because there will be a presentation on Wednesday precisely presenting this topic. All of that also on DCR grants. So to wrap up, I think that if we want to use robots to improve the processes, this is something we can do and we should definitely try to do. However, we need to make sure that we have these two steps in place, understanding what is going on and then redesign the current process to optimize some performance. In this presentation, I just focus on the first step because I think that's from a chronological point of view, this is the first issue we need to tackle. And to accomplish the first step, we need to understand the current situation. So for example, by using technologies like online process mining, and then we need to make sure that we understand the models that are being produced out of this online process mining. And in particular, when we talk about understanding, we need to make sure that we get the population right, and we get the task, the purpose of this understanding process right as well. Only then, I think we can define our data sets and our labels essentially for training robots so they can effectively help us. So thanks for your attention, and with this my presentation is done.
Thank you, Andrea. That's a very nice talk. So now we come to the questions. I asked that maybe you can, if you have a question, maybe write in the chat, and then we'll give you the opportunity to ask it in person. So I see, Thomas, you already wrote a question. Do you want to ask Andrea in person, or? Maybe. Otherwise, I can just read up the question. That's also fine. So Thomas was asking, great to see you use the DCR tools and understandability methodology developed in the IGNO project. As you know, the DCR tools also implement data-aware precedence and response relations, also with deadlines and delays. So have you considered how to use the online data-aware mining for the DCR notation? Ah, his microphone is not working. So
yeah, so actually, of course, I think it should be it should be done, and I do not think it should be particularly tricky. You know, we just decided in that specific context, we decided to use this NP declare, because essentially in a previous work we already did the discovery for declare language. So essentially we already had the technology to discover these constraints, and then we essentially just added, we were just able to extend it by adding the Höfting trees, so the data perspective on top.
Mm-hmm. Yeah. He has a follow-up question. How many of the declare relations do you use in practice?
Do you use in practice? I'm not sure what you mean by that. I'm assuming that you mean how many relations we're able to discover. I think our implementation allows us to discover just few of them. But in that paper, we showed essentially sort of a framework where you can just plug the different logic of the constraints, and then it should be, yeah, if you want to have other relations, it should be possible to implement them. But our implementation, I do not remember exactly how many relations, but just a handful of them. Yeah. So if anyone else has questions, please write in the chat. I have a question for you, Andrea. Yes.
So I think the online process mining, it's really interesting, but I was wondering, have you done any like real life case studies with this, where you actually try to apply this in practice for a specific domain, or?
No, we are trying to, we are in the process of doing that. Mm-hmm. But I agree with you that so far there has been a bit of lack of case studies for online process mining. I think that one of the problems with having case studies in online process mining is the challenges related to having the data available. So of course, if you want to share a log, for example, a real log coming from a real domain, it's much easier to anonymize it and therefore to share. Mm-hmm. Whenever we're talking about live data, then things are a bit more tricky, I would say. Mm-hmm. So I think this is one of the reasons for lacking case studies. We have one case study which are now investigating, which is related to security. Mm-hmm. Essentially some sort of intrusion detection system, if you will. So essentially analyzing the behavior of a system in real time to spot anomalies in how this is actually used.
Yeah, interesting. Thank you. So I see there's some more questions going in. Freddie van Rijswijk has a question. Would you like me to try and unmute you?
Can you hear me?
Okay. Yeah, we can. Okay.
Okay, that's probably.
Please go. Yeah. Please go ahead. Yeah.
Make your life a bit easier. Thank you for your presentation. It was very interesting. I'm always looking at from the other side, so I'm starting always with the business rules. Mm-hmm. Because when you look at the data, as you correctly said, if you go to your event streams, you most of the time don't have all the data that you need in order to get to the rules, right? Mm-hmm. And there is one interesting topic maybe for future research is that business rules are not black and white. So there is a lot of, say, enforcement level in business rules. Certain business rules you have to strictly enforce, otherwise you go to jail or you kill someone. Other business rules, like say speed limits, not everyone keeps the speed limit, right? So you have a certain level of enforcement. Are you considering to take that in your research as well, or?
I'm not absolutely sure I understood your question. I mean, okay. So let me try to answer. So it depends on which online process mining activity, let's say, you want to do. So if you want to focus on the discovery, like I presented in this case, then you're interested in the mainstream behavior that is observed in the data. So you're interested in what is the most typical, let's say, flow, the most typical path. There are other process mining and online process mining tools to allow to do, for example, conformance checking. And in that case, you're interested in identifying deviations from the rule, from the reference process. And then whenever you have a deviation from the reference process, you can also point out to what extent this deviation is, so how hard this deviation is from the reference process. So as you said, is the deviation of not killing anyone being violated, or is it just the violation of not, I don't know, not going above the speed limit violated? So of course you can, in that context, you can give different weights to different rules. And yeah,
Okay.
I'm not sure if that answers your question.
No, I think you're right. It probably belongs in a separate topic as well, because it's as someone meant soft constraints, etc.
Yeah.
Yeah.
Yeah. Yeah, now that you mentioned soft constraints, to be honest, I'm not aware of processes that are where this idea of soft constraints are in place. So I'm not sure if there are declarative language.
The difference is that most BPM implementations have hard constraints, right?
Yeah, indeed. I'm not aware of any system where these soft constraints are in place, to be honest.
And I'm working on a software product that works the other way around. So we start with the rules, and we have the ability to make rules soft. So which makes this process like a bit more diffuse and more hard to derive rules from. But yeah, if you have the rules, it's not a problem. But if you look in the reality like you guys do, then you don't never find the soft rules, because the software normally doesn't support the soft rules. Yeah. Okay. But
thanks for.
Yeah, understand. Thanks.
Thank you.
Right. Plina, I saw you had a question. Do you want to ask it in person or?
Yeah, sure.
Please go ahead.
So it's going a bit to higher abstraction level, if you may say. First of all, I like your vision, and according to your vision, we first need to understand what's going on. I mean, robots or so-called robots should discover what's going on and then suggest how to improve the process. But somehow in the middle, there's human understandability. Well, what do you need this for? It may be asked, what do you need it for if robots do all the work? So, but of course I agree with you that human understandability is needed here, and I think that it's not that automated algorithms can do everything about process improvement, but there should be some kind of human plus robots in this direction. So now my question is, what kind of understandability do you expect people to have to support the next step of process improvement? Because you said you want to see identified target users and what kinds of questions and goals. So what would you expect be important for the next step?
Okay, so okay. So,
yeah, it's a bit long.
yeah. So let me start from the beginning, and then we see if we reach the end. So your first question was, if robots are doing everything, why do we need humans? I mean, essentially, right? So I think the point is that robots are not really doing everything by themselves.
I completely agree. So the question is really, what do you need to support humans to do?
So the point is that you need to train robots, right? Mm-hmm. Robots are not improving based on their fantasy. The robots need some training data. And the training data, so a robot can be as good as the training data you feed to it.
Of course.
So it's absolutely important. My point is that it is crucial. It's the key part to make sure that we're feeding good data to the robots before, you know, having them to run around. So we need to make sure that these robots are robust and they're capable of really improving the process, which means that we need to feed data to these robots, and this data has to be super robust as well. Otherwise, we would end up with robots getting some weird optimization. And as I made in the example at the very beginning, for example, saying, okay, we need to remove humans from the process at all. That's not the sort of optimizations we want. So, and to have this good labeling of the data, we need to have a deep understanding of the processes, which are essentially the labels for the data, right?
Yeah, yeah. So it's a very good answer. So what you're saying is that the understandability is needed to be focused on enabling domain experts to label the data.
Yes.
So yeah.
Yeah, exactly. To train the robot. So if we're not able to understand the models in the first place, we cannot hope to be able to train the robots. We need first to master, let's say, the models, master the language, and then we can teach the language to somebody else, for example, to the robots.
Yeah. So yeah, this is very, very clear and very well said. And I'm not expecting you to answer, but maybe let's think of what kind of understandability or what features of understandability would support this labeling in future.
I agree.
Thanks.
And I agree, Nina. We should think about that. And as I mentioned also here on the slide, I don't know if you still see the slide, but our preliminary investigation on that shows that, for example, different, so first there are different notions of understandability, that different purposes are leading to different understandability levels. So the goal is associated with the understandability, and the subjects, so the population interacting with the models, is also another factor in the extent of the understandability.
Thanks.
Yeah.
So thank you, Efra, for some very nice questions. As Jan is also saying in the chat, we should go for the coffee break. So we will come back here in about 10 minutes to start the next session. I would like to ask the presenters for the two papers in the next session to stay around a little bit and talk to Sir about and make sure that they can share the slides and so on. So thank you, everyone, and we'll be back in 10 minutes.
So now it's 11 o'clock, so welcome back everybody. I hope you are here already. The first talk in this session dovetails neatly with Andreas' presentation because it also emphasizes data. The paper is called Evaluation of Heuristics for Product Data Models. It's by Konstantinos Barbotas and Anastasios Kounaris from Department of Informatics at Aristotle University of Thessaloniki in Greece. And the presenter is going to be Konstantinos Barbotas. Konstantinos will be using his video presentation, but do type out questions in the chat as the video goes. Then Konstantinos will be able to either answer live or we can take the questions afterwards. So, Konstantinos.
Thank you. Hello, my name is Konstantinos Barbotas. I am a PhD student at the Computer Science Department of the Aristotle University of Thessaloniki, and my research subject is business process optimization. I would like to present to you our paper titled Evaluation of Heuristics for Product Data Models. In general, this paper deals with data-centric approaches which over the last 2 decades have been emerging as an alternative to the more mainstream activity-oriented modeling approaches. We focus on a particular approach, a product data model, or PDM for short, based one. Two of its most distinctive features are the fact that it is declarative, in other words, it does not produce a particular workflow design per se, and that it is tailored to information-intensive approaches. For example, how to reach a decision as to whether or not to grant a loan to a client. The most advanced approach that derives a workflow design out of product data models to date is called PBWS, which stands for Product-Based Workflow Support. It proposes a set of heuristics which aim to optimize execution performance in a case-by-case manner. Our motivating observation is that these heuristics fail to benefit from established techniques in the field of data flow optimization. Next, we present our contribution, which is twofold. First, we propose a new heuristic, which comes in 3 flavors, for choosing the next operation for execution in a product data model, and which is inspired by existing data flow optimization techniques. Second, we conducted an experimental evaluation of existing heuristics while also comparing them with our proposed ones. Before delving into greater detail about our work, I will present the product data model, which is the foundation of the evaluated techniques. A PDM represents the structure of a workflow product as a graph. It consists of vertices, which correspond to data elements, and edges, which correspond to operations. For example, in the figure, we see a PDM referring to a mortgage application process. Each operation may have 0 or multiple input elements, and exactly 1 output element. For example, operation 1 has elements B, C, D as its inputs, and element A as its output, while operation 3 has element H as its input and element A as its output. The root element, which in this case is element A, represents the final product of the workflow. In the example, it is the amount of the mortgage, and it might be 0. The structure of PDM allows for multiple execution paths in each workflow, all of which produce the root element. Usually, the alternative paths have different execution costs and time duration, due to the different cost, time, and probability attributes each operation possesses. The attributes of our example can be seen in the table on the right-hand side. In the example, we can reach the root element in 3 manners. One of them is the path that begins with the execution of operation 7, which produces element E, followed by the execution of operation 4, which produces the root element. However, there is a 50% chance that operation 7 is not executed successfully, and therefore does not produce element E. In this case, operation 4 cannot be executed, and an alternative path should be followed. Next, we move to the derivation phase of workflows from a product data model. As we mentioned before, each PDM allows for different execution paths. Therefore, in terms of performance optimization, the question that arises is the following: which path of operations to choose for a specific case? To answer this question, PBWS proposes a set of heuristics. Now, it should be noted that these heuristics operate in a step-by-step manner. They assess each of the available operations for execution in each step and choose the best one. The heuristics used by PBWS are the following: random, in which the operation is randomly selected by the set of available operations; lowest cost, which chooses the operation with the lowest cost of execution. For example, let's assume that we are at the phase of the process where operations 5, 6, 8, and 9 have already been executed, and therefore elements B, D, F, and G have been produced. This means that the available operations for execution are operation 7 and operation 10. According to the lowest cost heuristic, operation 7 should be executed because out of the two, it has the lowest cost. In particular, it has a cost of 1 versus a cost of 3 that operation 10 possesses. Next, we have shortest time, where the operation with the shortest execution time is selected. Then we have lowest failure probability, where the operation with the lowest probability of not being executed successfully is selected. After, we have shortest distance to root element, where the operation with the shortest distance to the root element is selected. It should be noted that distance is measured in the total number of operations required for the production of the root element. Next, we have shortest remaining time, where the operation with the shortest remaining time is selected. Again, the time is measured as the sum of the processing times of the operations required for the production of the root element. Finally, we have the shortest remaining cost, where the operation with the shortest remaining cost is selected. The cost corresponds to the sum of the costs of the operations that exist on the path to the root element. Next, we propose our own set of heuristics. A knockout operation is an operation whose execution may lead directly to the completion of the process. For example, if the execution of operation 3 is successful, the root element A is produced and therefore the execution is complete. Our heuristics are based on the principle that knockout operations should be executed before non-knockout ones. The rank function that we use takes into account both the probability of an operation to produce the root element, either directly or indirectly, and the corresponding cost or execution duration. To showcase this, we assume an example where operations 5, 6, 8, 9, and 10 have already been executed, meaning that the available operations for execution are operations 2 and 3. According to the lowest cost strategy, we should execute operation 2, meaning that we would also require the execution of operation 1 for the production of the root element. This would amount to a total execution cost of 13. However, according to our proposed strategy, the rank value of operation 3, which is a knockout operation, is higher than that of operation 2. In other words, we should execute operation 3. This would amount to a total execution cost of 12, which is lower. As you can see, what sets our ranking function apart is the fact that the rank of an operation is based on the probabilities and costs of all operations in the shortest path from the given operation to the root element. Proposed heuristic comes in 3 flavors. The first one uses the formula presented before. The other 2 use the same formula, but they modify the denominator by employing the sum of the operation duration times and the sum of the product of the cost and times respectively. In all 3 flavors, the operation with the highest ranking value is chosen for execution. For the purpose of evaluating our proposed approach, we use 2 PDMs. The first one is the mortgage example that was presented before, while the second one, which represents a process from a social insurance company, is presented below. For each of the 2 PDMs, 100,000 random instances were created. The cost and time attributes were assigned values in the 1 to 10 range, while the probability of failure was assigned values in the 0.0 to 0.999 range. Here we can see the results for the mortgage product data model. In all graphs, our proposed heuristics are highlighted. In the first graph, we have the average cost per case. In the second graph, we have the number of cases where each heuristic dominates the others in terms of cost. In the third graph, we have the average time per case, while in the fourth and final graph, we have the number of cases where each heuristic dominates the others in terms of time. As you can see, in the first and third graphs, in both objectives, our proposed heuristics performed on average better than the existing ones, while also achieving the best result more times than the existing heuristics as well, as you can see in the second and fourth graphs. Next, we have the result for the social insurance product data model, and again, we present the same set of graphs. The results are similar, with our proposed heuristics again performing better than the existing ones, both on average and in terms of the number of cases where they managed to achieve the best result. As you could see in the presented graphs, the rank-based heuristics proposed in this work are the best performing ones, both when cost and when time is the optimization objective. It should also be noted that the relative difference is small and does not exceed 1.1%, which means that the rank function effectively covers both objectives in all 3 flavors. For the mortgage PDM, the best performing heuristics from the existing ones are the shortest remaining cost for the cost objective and the shortest remaining time for the time objective. These heuristics are on average only 4.2% and 4.6% worse than the rank-based ones respectively. For the social insurance PDM, the best performing heuristic in both objectives is the one that chooses the operation with the lowest failure probability. This heuristic is 6.3% worse than the rank-based solutions. A remarkable observation is the fact that our proposals are superior to the best performing existing heuristic by up to more than 20 times in some cases. Our proposed rank-based heuristics exhibited the best performance on average. However, there was no globally dominant solution. There are 3 directions that we would like to follow in terms of future work. First, we would like to improve our handling of operations with multiple input elements in terms of computing path costs. Second, we would like to develop hybrid methodologies that are able to switch between heuristics on a case-by-case manner. Finally, we would also like to transfer our techniques to other declarative modeling approaches. We have reached the end point of our presentation. I would like to thank you all for your attention, and please feel free to express any questions you may have.
Thank you for a nice presentation. I almost forgot this was a video. Does anybody have questions? You can type them in the chat and I'll try to read them out loud, or you can just talk. A little bit slow. Maybe I have a question. So in your presentation, one of the heuristics you used was there was a notion of knockout activity, one that would certainly lead to the production of the core. and then there was non-knockout activities where, well, it was fuzzy to me what it means to be a non-knockout activity. If it's one that doesn't get me closer to the goal, it doesn't seem helpful. Maybe you could find the slide.
Yes. Just a moment. For example, in the example we used, operation 9 is not a knockout activity because its execution does not lead directly to the production of the root element and therefore the completion of the process. Because for the process to be complete, we have to produce the root element or to exhaust all possible paths so that all possible paths have failed, and therefore the production of the root element is no longer possible.
Okay,
in contrast,
so when you say contribute directly to production of the root element, does that mean that neither FG or H could ever, no, H could be?
H, yes, could, but G contributes indirectly, which means that after its production, we also require the execution of several more operations for the completion of the process,
Right.
which therefore should make it more costly for the root element to be produced via the execution of operation 9.
Right. Okay. Are there more? Thank you. Are there more questions? So I have an additional question then. So you have little graphs you presented later in the presentation. It was a little bit fuzzy to me in the presentation how to read those, in particular the ones where there seems to be big difference between the columns, but it was too fast for me, so I didn't catch on to what I was supposed to take away from those graphs. Maybe you could show them again?
Yes. So can you see the graphs? So just a moment. Am I not sharing my screen? Oh, okay. Sorry. So you're talking about these graphs, right?
Yes, exactly.
The second and fourth one, if I'm correct.
Yes, the second one in particular, where it's cases where each heuristic dominates, and it wasn't entirely clear to me what that means.
Yeah, okay. So let's say that, as I mentioned, we have 100,000 random instances. For example, we have an instance where the best possible execution cost is 10. So in each instance, we find which heuristic is able to achieve this best possible performance objective. And in some cases, there are more than one heuristics. For example, maybe lowest cost and rank cost are able in instance 5 to achieve the best possible result, while in instance 6, only rank cost is able to achieve the best result. So,
right.
Yeah. And that's why if you sum the number of cases, you get more than 100,000, because in some cases, as I mentioned, there are more than one heuristics that are able to achieve the best result.
Right. So you had in the end of the talk the claim that interestingly your heuristics outperformed existing ones by up to 20 times. Can I see this in the graphs?
No, because this refers to particular cases. To be more specific, for example, if in a case the best possible result is 10 and our heuristic achieved this, then there were some cases where the second best heuristic was not able to be less than 20 times worse compared to ours. For example, let's say that the best result was 10, then the second best heuristic out of the existing ones was able to achieve a result of 200.
I see. Okay. We have a few more minutes. Does anybody else have questions? So one question that comes up a lot in the declarative space, and which was always also raised by Andrea in the keynote, is that for declarative models, there's a question of understandability. If practitioners actually, on the one hand, do understand their models, and on the other hand, if they think they understand their models. So do you have any comments on the understandability of these PDM models? I mean, how easy does people find it to understand them?
Yeah, okay. I think this is a valid point because compared to a traditional and imperative model, declarative models are somewhat more abstract and therefore maybe a bit confusing in terms of reducing the actual, in terms of accurately representing the actual structure of the process. But I think that this is a strong point because they can be used to monitor processes with many alternative paths. And a possible solution to this is the fact that after determining the best path for a case, then you can produce a workflow, which is much more easily understandable. And you can derive workflows, even BPMN ones, out of product data models. So even if PDMs possess a disadvantage in terms of understandability, and there are possible ways to overcome this.
Right. Right. Okay. Any final short questions? Okay. At a physical conference at this point, I would say let's thank the speaker, but I'm not entirely sure how that's done in Zoom. Maybe you can do a little thumbs up.
It's already done, the workshop?
No, the speaker.
Ah, okay.
No, we have 3 more papers and a little break and stuff. Let's thank the speaker, I'll say, and then that'll be it. And in that case, let's move on to the next speaker, who's going to be Vedavyas Etikala, who is from the Leuven Institute for Research on Information Systems. He's presenting a paper called Text to DEC, Extracting Decision Dependencies from Natural Language Text for Automated DMN Decision Modeling. And this is joint work with Sibut van Veldhoven and Jan van Tienen. So,
thank you, Doctor. I'll play the video now, and I'll share my screen. Yes. Hello all. Welcome to the presentation on Text to DEC, a novel approach for extracting decision dependencies from natural language text for automated decision modeling. I'm Vedavyas Etikala, and my research partner Sibut van Veldhoven, and my promoter, Professor Jan van Tienen. We are from LIRIS Research Center for Management Informatics at KU Leuven. Moving on to the presentation. Effective decision modeling has a significant value to business organizations to manage their decisions, such as loan credits or loan approvals or medical diagnosis. Introduction to DMN, or decision model annotation, as a modeling standard has contributed a significant surge of interest in modeling decision knowledge. It is no surprise that modeling decision knowledge, such as decision dependencies and decision logic, using DMN has DMN with the strong foundations in logic has provided with effective knowledge verification validation tools and also easy to build executables to power decision services and also applications for the end users. But primarily the question is, from where does the model come from? So the model comes conventionally via a manual modeling process which is a decision analyst building a model by consulting a domain expert or by going through the domain corpus. But this approach is costly and also time taking, and also it has a it cannot keep up with the domain changes. Therefore, recent research has moved towards more automated approaches, such as extracting models from the data logs. But data logs are not sufficiently available for all the problems, but the common knowledge representation or for storing the decision knowledge is text. So text such as decision policies, regulations, or rules and guidelines. And therefore, despite having such an importance for extracting models automatically from text, a little research has been done in this direction. Therefore, we propose a novel methodology using latest natural language processing tools to extract dependencies from text through a framework called Text2Deck. Going to the Text2Deck is inspired from relevant model extraction approaches in process modeling and rule modeling. So we have formulated the framework in three stages. One is identifying the target text and processing the text through NLP pipeline and extracting the dependencies and concepts and converting that extracted information into a DRD or a decision requirement diagram. Moving into the details of framework, the first stage is text selection. We select the text through a pattern matching approach, pattern-based approach, to identify the declarative sentences and conditional sentences. So these format of sentences are more likely to give us information about concepts, dependencies, and also logic. So once the text has been selected, it is being fed to NLP pipeline. NLP pipeline is a tailor-made amalgamation of different NLP algorithms. So which can be classified into two levels of analytics tools. One is semantic analysis and another is syntactic analysis. In semantic analysis, we initially pre-process the text by cleaning up the text and then improving the text by fixing the coreferences and anaphoras. I'll talk about this in more detail in the next slides. And in the next stage, syntactic analysis stage, we identify the concepts and we identify the dependencies and we extract the dependencies out and we formulate them as a list of tuples in a format of active verb and action verb and base concept and derived concept. So going through in details of semantic analysis phase, once the text has been pre-processed and cleaned, it goes through coreference resolution step. This step addresses the cross-referred concepts and aligns them so that it gets easier when we move on to building the decision requirement diagram. So if we consider this example, here we have a level of obesity, which is a token, but which has a coreference to the previously occurred concept called obesity level. So aligning these two concepts makes us easy in the future while building the dependency graph. And anaphora resolution. Anaphora is also just like co-reference, but it deals with the pronouns and ownership of the concepts. Here you can see like patient risk level should be assessed from his obesity level, waist circumference, and sex. So here patient and his are referring to the same person, patient. Therefore, this patient will be propagated over the conjunction to in place of his and also other places. And the next stage, next step is concept recognition. Concept recognition is done by joining the collective nouns into noun phrases. And this noun phrase like health risk level is merged into one concept called health risk level. Similarly, obesity level and waist circumference. And the next step is dependency parsing. Dependency parsing deals with identifying the underlying grammatical structure and relationship between the different concepts and action verbs in that sentence. So once the action verb has been detected and this dependencies have been extracted out using the action verb and the concepts involved in it. For example, here we can see health risk should be accessed from obesity level, waist circumference, and sex. Here we can see that health risk level has been derived or dependent on obesity level and waist level and sex. And in the last stage of DRD construction, from the list of tuples and dependency tuples and list of base concepts and derived concepts, we determine input nodes. Input nodes are the pure base concepts and decision nodes are the derived concepts, and information requirements are the links between them. So we formulate an DRD by joining the nodes. Like well, if a node occurs as a decision in one component and as a leaf in another component, it becomes an intermediate node in joined component. And this whole DRD is represented as an XML because which can be visualized in tools like Camunda and other representational modeling tools. So we have evaluated this framework text-to-deck with a hand-picked examples from real cases. Like for example, here is a prepayment example from customer prepayment policy, and when this example has been fed to text-to-deck, the intermediate result would be a list of dependencies, and the final result would be the DRD formed from these dependencies. So basic challenges which this framework encounters is challenges from an NLP point of view, like such as ambiguities in text, incompleteness in text, and non-trivial anaphoras and coreference are very tricky to detect. But with the assumptions like legal texts are more structured than informal language, gives us a bit courage to go with this approach. And modeling challenges from a daemon point of view, that is like identifying a primary decision could be a difficulty when it is not clear which decision is a primary decision, or like if there are disconnected components and redundancies and circularity in the DRD formed, it would be a partially complete DRD. Therefore, only reachable components are considered to be a part of DRD. And for the initial research efforts, only input nodes and decision nodes are taken into consideration. And as a conclusion, we can say that text is a very popular knowledge source for decision models. And text-to-deck provides an insight about how to extract interpretable decision models from this textual resource. And it efficiently cut down modeling time and cost. And also, as a future work, there is like huge potential and towards chatbots, personal assistants, and explainable decision making, and also generating text from DMNs and conformance checking. Here are some references, and thank you for your attention.
Thank you for a nice talk. Again, I think the video format worked out beautifully. Are there any questions? So Claudia has a question. Claudia, do you want to speak it out yourself, or should I?
Sure, of course. I can do that. I just wanted to sort of prioritize in the list. No, just kidding. All right. Thanks a lot for your presentation. That was really interesting. Thanks very much. Also very nice. I mean, I appreciate research a lot. Yeah, of course, I'm very interested in your outcome. So please keep us apprised, but also the future development of it. I had especially a question because at least in the experience we had with some colleagues of ours, that was something very tricky to deal with, which is when we deal with legal texts, very often happens that the legal text says, according to norm number, blah, 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 and the previous norm, blah, blah, we extend it with this further, right? With this further requirement. So this looks more like a sort of second level co-referencing because it's not anymore like subject to subject in a previous phrase, but it's really entire rule.
Yeah.
So any hint from your side in light of your experience?
That's really a very interesting question. And it is like a very important idea of co-references and anaphoras to be resolved to get an optimal and very joint model instead of disconnected components. So with latest state-of-the-art packages in NLP tools like neural coref or Hugging Face, other packages, the trick is the probability of it works with the probability of a previously occurred word to be related to the current word. So as the distance in between the words increases, the probability goes very low. So when it depends on a modular or like a modal interaction, means human interaction might be needed in selecting which one is applicable more. So I mean to say, if there's a low probability, there's a highly unlikely that it will be picked as a co-reference to be resolved in this case. Like if it is like beyond 2-3 paragraphs or it's in a totally previous page, it's hard to detect.
Understood. Thanks.
Hope it answers your question.
Yeah, it did. Thanks. Sorry, it's basically like involving the human in the loop at some stage. That's
yeah,
of course.
So
I'd have another question, but I don't want to, occupy the stage. May I?
Sure, please ask the question.
Please go ahead, Claudio.
Thank you. Sorry, another thing that really tricks my mind, I'm sorry if you already stated that and maybe I missed it, but is when we have the negative clauses, but not like in the standard version, like don't or the not written like that, but things like cannot, shouldn't, or this kind of particular compressed forms, which basically negate the ending of the sentence, or either in part or the entire sentence. So how do you deal with negations usually?
Negations haven't yet considered, but it is taken as a full concept right now. Like it is not dependent on, or is it dependent on, or it is not dependent on is also considered as a dependency right now. So, but if it is stated clearly that it is not dependent, then it would, with the filters, pattern-based filters, we can avoid it. But if it is very cognitively tricky, that it is involved somehow, it is negated in the future. So like in the sense, like they're not considered or are unlikely to be considered. These statements are not clearly obvious. So NLP tools will pick it up in the instance, and the more training we do, there's a bit of scope of improvement on avoiding these nots.
Mm-hmm.
Yeah. So we would take it as a future research to incorporate all the patterns possible.
Thank you.
Okay, the next question is Stefan Harman. Stefan, do you want to ask yourself?
Sure, if you can hear me.
Yes, fine.
Yes.
So thank you again for the presentation. I also enjoyed it a lot. I always like the presentations and papers and work on DMN. So I was wondering, thinking about understandability and how easy it is to comprehend the model that you derive, did you consider or do you support to abstract multiple data inputs into one? Because you, for example, had a lot of information of the patient that is considered, and then seeing, oh, it's one patient, and we could also consider the weight and the height at the patient's physique and offer a higher level of abstraction to the user or to the knowledge worker looking at it.
That is an interesting perspective to look at, but I'm not sure that user want to get the overview of it. But as a point of a modeling point of view, when we want to build an executable applications, so where it requires independent inputs, it needs a user heights and the user's weights, and then it's better to keep them as separate inputs than merging into one physical physique. In terms of applications, I think it would be useful, but if a user want more quick understanding or like a question answering point of view, like what BMI is dependent on, then he would if he expects the answer to be just physical physics, then it could be useful. But yeah, I think that's like some future work which we can look into.
Can I add something to that, Søren?
Yes, please.
I think it's always the intention to have a human in the loop, and there is no automatic outcome. There's always a human who has to judge the model, because it's hard to do this in a tool and say this is the perfect level of detail. Certainly in DMN, if you have large decisions with numerous data, you have to somehow include the human, I think.
Yeah.
Okay, thank you.
In that case, Freddy van Rijswijk asks, well, Freddy, do you want to say it yourself?
Yeah, I was wondering which libraries you are using, CPT3 or which language models?
So we are using Python packages, especially provided by Spacey and standard NLTK and standard NLP and Stanford NLP and NLTK packages, and we have seen which algorithm, which tool applies best at a different stage, and we tailor-made this pipeline to work best for this problem. But still it is in the improvement phase, so we would do further more testing and would improve it based on if anything more recent becomes available in the market.
Thank you.
Thomas, you had a question? Just assuming your microphone is operating.
I think it's working now.
Oh, yes.
Hello, everyone.
Hello, Thomas.
Yes, a very nice talk, a very nice presentation, and a very interesting problem. Really liked it. So I just said that we had some support for NLP in the DCR highlighter tool, but no support for data. So it would be really interesting to see if it could be integrated. And I know people are asking for DMN support as well. So I was wondering, is the tool you're making open source, or is there some way of trying it out together with others?
So the tool we are using is still not released as an open source. We are conducting some more tests, and we would like to improve it on further and then make it available as an open source once it reaches a good performance level. Hello, does that answer your question, Dr. Thomas?
I think it did. But we'd be very interested in trying that out, I think, at some point in the DCR tooling community. So I wanted to add a question of my own. So looking at the examples, at the example text you had, the tool was in the favorable position that every part of the text had to do with the construction of the DMN diagram. But what if I give it a slightly larger text where there is included sentences about other things? So for instance, in the medical example where you said that the weight and obesity had some weight, if I added a sentence to that saying, however, in general, we should not prejudice against people who are overweight, right? Which is like a fluffy comment that is not supposed to go into the DMN table. What will your tool do with that?
So I understand your question as like if there is a noise in the data. So if there is a noise in the data, it can be discredited when it comes to the DRD construction. Though there is a dependency identified in that term, but if there is no dependency between the sentences, so it would be an independent component and disconnected component in the final DRD which generates. So that makes it like a, as I mentioned in the assumptions, that we only currently consider the fully connected component as one DRD. The loose components and disconnected components will be removed. So like positive testing and negative testing is yet to be done, and so that to check how it performs better to when it's like a high tricky noise.
Can I have a question?
But I'll allow myself a follow-up since we have a little bit of time yet. So suppose I use the entire Danish law on social service as input to your tool. So this law contains a number of small sequences that would be very adequate for the tool, where it would decide that the way you compute whatever social benefit is by adding these things together, right? But this would be spread out across large number of paragraphs saying stuff like, okay, you have to be actively pursuing a job, yada, yada, things that are not supposed to go into decision modeling notation diagrams. So what would your tool do with it?
So in the first stage of NLP pipeline, we take the text, we select the text based on the patterns, but it is confined to like one paragraph or two paragraphs. So it won't span across scanning full document. If it kind of gives very noisy data and very unpredictably different like a overview for the tool to do anything. So for now we are focusing on one or two paragraphs, and we pick the statements which follow the typical patterns of like subject, object, verb sort of declarative sentences, or if A then B sort of logical conditional sentences. So these sentences are occurring in around the same group of paragraphs, but not spanned across the whole document. Dr. Soren, your voice is...
Sorry, there was a thank you. There was a question voiced but not written. Did somebody want to ask a question?
Yeah, it was me. So, can you hear me?
Yes.
Okay.
Could you say who you are, because it's not entirely obvious?
Yes. Hugo Lopez from ITU and DCR.
Oh,
thank you.
Hey, Hugo.
Yeah. Thank you very much for your presentation. I have a couple of questions. Well, one question because we were lacking of time, and it's the selection of your language model based on kind of a forward and backward references. When we look at the low text, we have things that are very simple with the transformer models that are basically things that come from the history of your sentence. So if the release of payments will be given according to event B, C, and D, but there are others that are looking at forward. So, for instance, this event should not happen whenever these these activities get fulfilled. And these are kind of forward references. Normal with classical transformers, these are really difficult to look at. Have you considered models like a BERT or Big BERT in order to consider forward references?
Not yet, but that would be very interesting suggestion to include in this tool, forward references.
Okay.
Yeah.
So we're somewhat over time, but there seems to be some interest. Does anybody have a final question before we take a short break before the second session? Okay, in that case, let's thank the speaker again. You do this by going to participants in the bottom, click the more button, and then click the applause button. Yes, I see that several of you succeeded with this. Again, you go to the bottom of the Zoom window, you click participants, and then there's there are icons in the bottom. You can click more and then click the clappy hands. Okay, in that case, thank you for a very interesting session. Let's have a 13-minute break before we reconvene at noon. If the speakers for the next session could please get in touch with Jan or Claudio, or just call out loud in the chat so we can be sure that audio and video is set up properly. I'll see you in 12 minutes.
All right, see you.
So for the talk by Yao, I can't remember if it's the first or the second one. The paper that Sven and I also. Let me check the schedule.
Sorry, what was the question?
No, I just wanted to tell Jan and Claudio that Yao can present, but I'm trying to remember if we are okay. We're the last one. Okay, so for the last talk, Yao had to leave because he has he's becoming an associate professor today, so that was somehow more important than giving the live presentation.
Come on, just for this. Oh, damn it.
So he asked if we could just play the video. Would you prefer that I do so, or maybe you as session chair?
I prefer you do it.
Okay, I'll set things up so I'm ready to click play when it comes up. That's fine.
And who's the first? Stefan is the first one. Yeah. Okay.
So let's see.
You play the video or you go live?
I intended to go live.
Okay.
Oh, that's great.
I think that's really nice. Like I really. Yeah. Personally, I think it's very nice when that happens. So. I'll just try mine quick to see if it all works as it should.
Yeah, that would be great. So if you could try first, Dice, and then we try with Stefan, that would be awesome.
Yeah. So this one. I think you see it, right? Oh, one second.
Visible. Yeah.
Yeah.
Hello, my name is Robert Faselko and I'm presenting our work on
Yes, we
Reader,
also
a
can hear
reactive language for
audio.
processor systems
Okay.
natively supported on a graph.
Perfect.
Good. So
Great.
Stefan, could you
stop
take
sharing?
over? Mm-hmm.
Sure, I will try. Show. Okay, do you see my slides? And can you hear me?
Yes, beautiful
Okay.
picture. Wow.
Just some stock image from Sevilla.
Okay, we don't need to say everything, right? let's live with that.
If my taskbar would hide, you would see the credits, but yeah, whatever. Good.
Thank you. Okay, so I'll honor the coffee break now.
Yeah.
Yeah, me too, actually.
See you in a minute.
10 minutes.
Hi all. So I see Stefan is already smiling, up and live. So does Thijs. So, but this is Jan's session. So Jan, please, the stage is yours.
Okay, let's start. So we have two more presentations. One by Stefan Harman and Matthias Weske, data object cardinalities in flexible business processes. Stefan, you present live, or yeah?
Yes.
Okay, go ahead.
Okay. Good. You see my slides? You hear me clear?
Yes.
Very good. Okay, so welcome also from my side. Thank you for the introduction, Jan. Today I would like to present to you my work together with Matthias Weske on data object cardinalities and flexible business processes. And by flexible business processes, I mean first knowledge-intensive business processes, which I characterize in the following. So first, it is flexible, meaning it has many different variants, and during runtime, we may choose one variant or the other based on the information and based on specific properties of this case. And this leads to a scenario where we may have an underspecified model. So at design time, we do not all the situations that may occur, or we do not want to specify them explicitly, leading us to an underspecified model, which may require adaptation at runtime once such an unconsidered situation occurs. And then we have a lot of decisions that need to be taken during the process. Therefore, knowledge workers consult the data that they have and decide which variant to choose, which activity to execute next, or how to execute a certain activity. And the data that is required may even drive the process. So, meaning that if we need a certain data object to do a decision, we may first execute the activity that actually produces this data object. And a very prominent example for knowledge work and knowledge-intensive processes are a lot of healthcare processes where we have the physician as an absolute expert who probably knows better what to do in a case of a disease than any software developer or business process management expert. And when we at the BPT group from Professor Weske talk about flexible business processes, we usually follow the fragment-based case management approach. And we heard earlier today in the keynote from Andrea that there are different ways of hybrid modeling for processes. We could, for example, model the same process through different models. We could have a legal text and a DCR graph, both expressing the same process. Or we can use complementary processes. We may have, I don't know, a product data model together with a decision model to decide which path to take. And in FCM, we also have different models, and we kind of complement each other, but also overlap. So they also model the same parts in part. So first of all, we have a domain model. This domain model describes the classes of data objects that may occur in our case and the associations among those classes. Here you see the example of an academic conference. So we have the conference object, we have paper submissions, author teams, reviewers, and so on. There's one particular object that is the case class. And we say that this kind of refers to the case, saying there's exactly one conference for a case. And around this object, the process evolves. Then we have object life cycles. For each of these classes, we define the states and how we come from one state to another. Then we have the fragments. The fragments are kind of the core of the process definition, and one can think about them like small business processes, small BPMN business processes. So here we see three different fragments. Each of these rectangles contains one fragment. We have one with the start event, naturally starting our case. So when the conference is scheduled, we can publish the call for papers. Now, similar to business processes, when we model them in different models, they can be instantiated more or less separately from another. So after we published the call for papers, we could continue by sending out the call for papers, but we also have all the prerequisites that we need to open the conference for submission and could also continue here in the second fragment. Once the submission is open, we can continue with the third fragment, basically submitting a paper. And this can even be done repeatedly. So we can submit one paper, can submit another paper. We can do it concurrently. So even submit the next paper before the first send submission or submission notification has been sent out. This leads to very dynamic behavior, and it allows for runtime adaptation by adding new fragments at runtime. Finally, the last part of our process specification is the goal. The goal is specified as a so-called termination condition that specifies which data objects need to be in what kind of state. For example, we could say the conference must be in state closed for submission, and only then can we close the case. Now, we thought, okay, we already have data models here. What would happen if we add further constraints to, for example, the data model? And we did so by adding cardinality constraints. Here, for example, we can interpret them like the UML multiplicities, saying that a conference may have or may be associated to up to 1,000 papers. On the other hand, a paper is always associated to one and only one conference. Inspired by the object-centric behavioral constraints, we thought we can also add another one, another kind of cardinality constraints. So first, what's maybe important is that cardinality constraints are not only structural properties. We can also view them from a behavior point of view. If we say that every paper requires a conference, the conference object must be created before a paper can be submitted. Now, coming to the second type of cardinality constraints, we call them the goal cardinality constraints. And these are kind of temporally qualified, and they refine our global constraints, saying while a conference may have up to 1,000 papers, but also 0, it in the end must have at least 50. This may be a little bit unintuitive, so maybe we look at the reviewer and the paper, or the reviews and the paper. Initially, a paper has no reviews at all, but in the end, we want to have at least 3, maybe even 4 reviews for a given paper. So the global cardinality constraint, 0 to 4, is never violated, but the goal cardinality constraint must hold upon termination. Now, like I said earlier, these constraints have an impact on our behavior. And now I would like to go through some of the examples, and first and for all, of the consistency between the different model types. If, for example, we have such a mandatory relationship, every paper requires a conference. The conference is required to submit a paper, and thus the object must be read by the respective activity to establish also to establish the relationship. So furthermore, we may have one-to-one relationships where we say every paper has one author team that wrote that paper. In this case, both objects must be co-created. So neither the paper can exist without the author team, nor the author team can exist without the paper. There are also other scenarios. We do not mandatorily have one-to-one relationships. We may also have a lower bound that is greater than 1. Here, we add a decision to our domain model, saying the decision encodes whether a paper got accepted or got rejected. In order to make a decision, we must consider the reviews for that paper. So we need 3 to 4 reviews to create a decision object. In the process, we need to consume those multiple review objects. So we realize some kind of batch processing where we say, okay, all reviews that we have for that paper need to be consumed in order to create one decision either in state accepted or rejected. And here we use the paper object as some kind of a reference. The paper, while there are many, many reviews in the system, probably, if you look at EasyShare, we only are interested in the ones that belong to that specific paper we are currently making a decision on. So based on the paper object that we consume and bind to the activity, we decide which review objects to bind and consume to the activity. Besides these consistencies, there are other properties. So for example, the goal cardinalities. Those must hold upon termination. We have said that we, for example, need 50 papers for the conference before we can close the conference submissions. Otherwise, we need to have another extension and yet another deadline extension so that the conference can take place. If we look at the fragment where we open the submission and close the submission, there is no such requirement. But looking at the overall process, we can see that after we close the conference for submission, there is no way that new papers can be added. So this goal cardinality constraint, 50 papers at least for a conference, guards this activity. It is only enabled if we have at least 50 papers submitted. Similarly, we can have lower bounds. And this was lower bound, we can have upper bounds. Papers and the associations to conferences are created by the submit paper activity and the whole fragment that includes this activity. Since our cardinality constraints constrain how many associations an object may have, it also constrains how often this activity and consequently the fragment can be instantiated and executed. So suddenly we may have a we most likely have a bounded behavior by saying that every cardinality constraint has a defined but arbitrarily high upper bound. And that is mostly it that we had so far. I would like to summarize it. So one of the primary concerns when we talk about knowledge-intensive processes is to find a balance between guidance for the knowledge worker. So the knowledge worker should get as much guidance as possible, and flexibility on the other hand, because we do not want to constrain our knowledge workers too much. They still should do the best, the actions they think are the best due to their expertise. When we now take a domain model, extend it with cardinality constraints, and integrate it with our knowledge-intensive processes, we can improve the guidance because we refine the behavior of the process. For example, by limiting or explicitly defining the context in which objects need to be created, by showing where we must perform batch processing, so consuming multiple objects, for example, to create another, or by implying lower and upper bounds for fragments and activities. And finally, by refining the goal definition by saying, okay, besides a certain state, we also require a certain amount of objects. On the other hand, I would argue we do not really remove anything from the flexibility point of view, because those rules, those constraints have always been inherent to the domain, and we now just making them explicit to the process behavior. So this is research in an early stage. I would be really happy if you have questions for me or just some points for discussion, and I'm now open for that.
Okay, Stefan. Thank you. I see already 2 questions in the chat here. First from Søren, who is the knowledge worker in the conference submission example?
Yeah, a tough question. So probably, it's a little bit of an artificial example, which is still relatively straightly structured. So this would be the case if there are no fixed rules for when activities need to be executed, and then probably the conference chair would be. But yeah, it's an artificial example and does not really fit the domain of the knowledge-intensive processes very well. But it has a lot of data objects and it has a lot of repetition and kind of showcases the different aspects in a very small and concise example.
Can I follow up on this?
Sure.
Yeah, sure.
The question as posed was very brief, but thank you for an interesting talk. And I think this is very interesting work. I'm totally on board with the object-centric idea that we need to sort of somehow couple data generation with the activities of a process. And I think this is a nice step in a direction of something that is so we say, less involved as a formalism than the object constraint-based systems. So that's very nice. You make a nice point here when you say that maybe the conference submission is too inflexible, too straightforward somehow. And this is just a random comment, I would conjecture that this is the case for the data generation parts of a workflow, usually, right? So my intuition would be that it would be very seldom that data is generated as freely as we want activities to be executed.
Yes.
Okay. Question from Des, and I had the same question actually. The cardinalities are shown in the data model, but do you also show them in another notation, like in declare or DCR graphs or somewhere in the process, or just in the data model?
So far, we include them just in the data model. We continued our work on this. So one thing that we already have here is that we have at least those indicators if there are multiple for the set indicators. And besides that, we did not use DCR graphs or declarative notions to that, but what we did, we also extended the object life cycles with data cardinalities, because our state transitions are guarded with these cardinality constraints. We can only make the transition from open for submissions to closed for submissions if we have the required amount of paper objects, or we can only accept or reject a paper once we have enough reviews. That we did.
Okay. Was that an answer to your question, Tess?
Yeah, thank you. I think, well, I mean, would you consider using maybe also other notations, or do you think this, the more data-centered notation is just the best one for this case that you consider?
Yeah, so in general, we also always consider declarative rules. So far, we use them in model checking and verification. We had a paper last year in this workshop on that topic. But in general, it would be interesting to kind of extend the hybrid approach to a declarative model that adds kind of these rules, but not as a replacement, more as an addition from our point of view.
Okay, thank you. Yeah.
Okay. A question from Hugo Lopez about the goal decomposition strategy. How about dynamic goals?
Yeah, currently we do not support dynamic goals. We may have multiple conditions, one of which must hold, but the goal can currently not be refined at runtime. So one of our prime examples, or my prime examples, is if you have a hospital process, emergency ward, it usually ends with the patient being discharged, but what if the patient does not survive? We need to adapt the process and have a new goal, or not a goal, but a termination condition for that. It's currently not supported, and definitely something for future work. What we still allow at some point is, or want to allow, is to refine it further. So not saying we can make it more general, that would be not with much value, but if we still can add more papers, we could still change the process. But at this point, we would need to, again, check the consistency with the change before applying the change to the running instance.
Yeah, that's really nice, but it's also kind of a challenging thing, because each fragment might have a different perspective. Like, say, I have one fragment, the process at the view of the manager, and another the view of the employee, and they are contrary. So finding kind of how do you decompose this, and sometimes actually how do you find that this inconsistency might be actually accepted because I dynamically add a new goal into the system. That's like.
So we have only few case studies, or maybe only one in the SMILE project, previously with Sven, Ida, and Luisa, I think are both in this call. And so far we did not encounter or model any example that has this need for dynamic goal. There's a lot of more thought that I have to do on this topic, I think, to answer this question properly and how it would be done. And also the question on how to best derive fragments to take different views or to use the data objects as a point of view is also not really decided or determined. Sorry to not be able to give you a right definitive answer.
Gives me the impression that we have to change the name of the workshop to Declarative Decision and Data Approaches to integrate everything.
D to the power of 3.
Yeah. Søren has a question of the output of a mining process. Søren, are you there? Maybe you can formulate the question. There's no sound. There's no sound.
Yeah, I'm struggling with Zoom, apologies. This formation you're constructing, as you mentioned, it seems unfinished, like there is, well, unfinished, unfair, but on the slide that's currently on, for instance, you had this connection that some paper, the decision on a paper uses the reviews obviously for that paper and not other reviews.
Yes.
But this is not represented in the graphical notation.
Yes, that is not presented in the graphical notation. We are currently working, I think I can say that much, together with Marco Montali on a full formalization of this approach. And so far, still in the visual representation of the model, we do not explicitly make it. So we say there is, here you see it, we have the paper class, we have the decision, and there is and the review, and there is an association. And it's those two objects that kind of are used by this activity. So it's pretty clear that the one that is not used in a batch is the reference object, and the other one, then we say all of them is consumed. We do not allow any other option at this point. And we say if there would be multiple potential reference objects, then it should all, they should all kind of determine the same set of reviews in this case. So these are some strong assumptions, and I think we need to look at some examples, some case studies to see whether these are valid or not.
I think that's a very interesting approach. I'll just follow up briefly. I know we're a little bit over time. You said that when you see the constraints on the upper left, then that constraint has to be consumed at some point, right? So that the decide on paper is the point where the views for a paper are consumed.
Yeah,
and you do this
red,
linearly.
sorry, red is the right word. They're not consumed, they are still there.
Right, okay.
I'm sorry, we do not destroy data, we just...
Okay, right. Okay, thanks.
Sorry. Was my Petrinet mind thinking.
There are some comments in the chat, but I think we round up the questions here to go to the next presentation.
So, Stefan, maybe you can address the remaining questions in the chat.
Yes, I can do that.
Okay.
Okay, then I will.
All right, thank you.
Stop the sharing.
I suggest you hit the applause button. And then the next presentation is about reactive data-driven processes as graph databases, which is presented by Zhao, who was promoted today. So the honors are taken over by the video, and I think Thomas will answer the questions. Am I right, Thomas?
Yes, I will be here.
Okay. So can we bring up the
video? I'll share the video. Let's give me a second here. So can you all see it?
Hello, my name is João Costa Seco and I'm presenting our work on RIDA, a reactive language for processor systems natively supported on a graph database. This is joint work with Leandro, master student at Nova University, Søren, Thomas, Thijs, and Hakon in Copenhagen. So the core of our work is to improve the experiencing of designing process-aware systems. We aim at improving the construction and reasoning capabilities of developers when considering the typical layers or views of a software ecosystem: processes, business logic, and data. The separation between these layers and the use of different languages and manual translations hinders the correct representation of processes, their evolution, and the reasoning about the full process and application behavior. The connection between activities and events and the corresponding data and data processing code is also many times informal and hard to soundly create and evolve. Also, it's not easy to define process instances using process languages, or to refer to process instances, and to relate dynamic conditions with the instances of these processes. So our aim is to unify the semantics of processes and data, or to unify all of these layers in a single programming or definition language. We aim at giving a common semantics to both processes and data, including all the business rules. We want to map data and control relations to a graph model with significant representation advantages. Using Reader, one can define a process in a declarative way, define dynamic conditions on the process, and may refer to the state, which may refer to the state of any process instances, and even use aggregate information on those conditions. We aim at compiling down this language native code to the Neo4j database, and hence discard the use of an external execution engine or monitor for the process, and allow for a standalone execution of the process. So this work explores the foundation of our previous approach on the language Reseda, which already explores the connection between reactive agent processes. It extends and generalizes it into a more fundamental presentation, and therefore is used to support a simpler transformation to other target systems like Neo4j in this case. In principle, Reseda can be encoded in Reader. Okay, so this is a more fundamental approach. The control flow of Reader is built on top of DCR graphs, and its reactive behavior and data dependencies are implemented as an extension of standard DCR semantics, or translating into the standard DCR graph semantics. The goals of Reader are similar to the ones of OCBC, which intend to make explicit the relation between processes and data. And Reader also provides that actual implementation code, which allows for not only execution, but reasoning across these three layers. The semantics of Reader also adds a reactive behavior to that one. That one can find in spreadsheet models, which is where each cell is refreshed whenever its dependencies are updated. One of the features that Reader also includes is the capability of dynamically shape the progress of a process according to the state of the different instances, or aggregate information of all the instances. This can be found in approaches like case management model and BPMN, but here in Reader we actually compile that information to code, which guarantees the execution of those conditions instead of relying on some external monitor to impose them. So our technical approach is composed of several pieces that unify this vision. Reader captures both the persistent state of the process and the control flow. So Reader is a typed core language that captures interactions, system interactions, input and output, computations, control flow, and the structure and relation of data. The state of a Reader process includes all the data elements that compose the instance of all running processes. Reader also defines dynamic state-dependent control rules, which can be turned on and off according to queries on the state of the process itself, so metadata, and also values of the data elements and data relations. The second component of this system is the Reader compiler, which translates Reader into native code of the graph database, Neo4j. So every dynamic behavior is encoded in triggers of the database, which allows it to run standalone, as I said before. So the compiler matches data elements of reader to Neo4j nodes and data relations, or relationships between nodes, and all the process semantics into triggers. The implemented semantics is inspired, as I said, in the semantics of Reseda and all this DCR variants proposed before. So the difference here is that we can naturally query the state of process instances in a safe way without using encodings or keys, and to also shape the behavior of a process. Communicate with external systems, we also include a module that provides standard REST interface for all the available interactions represented in the database. So the middleware communicates only with the database to interface with the external systems. So just to briefly present the language, we can look here at the syntax on the left and some examples on the right. So to highlight first, what is a process in Reader? A process is composed of three things: data elements that contain all the values stored in our database and can comprise all the data introduced and computed by the process. Control flow rules that defines the behaviors included in the process, and data relations that allows the user to add more information and structure the information, the data in the model. So in this setting, we implement nested scoping and static resolution of names, and the data elements can be given identifiers and then referred in relations and control flow rules by those identifiers. So we next present the data elements. So data elements highlighted here on the left can be of two different kinds: either input elements or output elements. Data elements, in general, we call them data elements. So input elements are given a type, and only values of that type can be accepted as input. Output elements, or computation elements, have an expression that is computed based on the other nodes or other data elements referred in the graph, and their value is refreshed every time the references are updated. So moving on to the control flow rules. The control flow rules are derived from the DCR graph notations and include the include relation that will include the data element on the right every time the element on the left is executed. So this loan book element will be available for execution later, including, excluding the dual operation, so excluding from a future execution. Then a precondition or condition relation between these two data elements that enables the second on the right hand side data element to be executed only if the first one was executed, or a relation that turns the element on the right as mandatory if the element on the left is executed, and then a spawn relation that will add a whole process P to the context every time the element on the left is executed. Executed means either is an input element and is given data by the outside, or it's a computation event and is recomputed somehow. We also have conditions attached to these relations, which can, of course, give more dynamic, include more behaviors, possible behaviors to be expressed in this language. So we then have data relations, which follow basically the scheme of Neo4j syntax for data relations. So we build on that. And we give it labels in order to then use them in queries. Of course, we have the query language that can be used in the relations before that follow the cipher language, the query language for Neo4j. And then, of course, an expression language, sub-language that can refer to regular values or base values, and can also refer to data elements and their attributes. And just to conclude, I will give an example. So suppose we have a create author data element, which is an input data element, which means that some endpoint is available to trigger it, to execute it. And whenever the create author data element is executed and given an author name, there's a spawn relation here that will add new data elements to the context whenever it is executed, and these new elements will have the values that were given to the first one. Okay, and notice that this second data element is also an input event, and will create a book for token. Okay, if token is the value given to the first element. So this works like a closure in this context, and it's an action specific for this author. And of course, create book follows the same structure. There's a spawn relation. If executed, it will create one element, which is the book Hobbit in this case, and for Hobbit we will create also an action, in this case loan book, and whenever the loan book is executed, then a new loan element will be created just for Hobbit, and then the return book is an action that is related to this loan, and it will include the loan book again, which was excluded when it was executed the first time. And so each one of these elements is like a row in a relational database, and the actions are the like closures that will work on these elements. So just to conclude a bit over time, we have an implementation coming which is almost complete, but will be available soon. And in conclusion, to say that we presented the language that unifies process and data in a declarative and reactive way, and allows one to read to reason about all the three traditional layers: processes, business logic, and data. And we have developed a compilation procedure that translates reader into native code of the target database, and allowing for a standalone execution of the process. So thank you very much. I'm looking forward for your questions in the workshop. Thank you.
Okay, thank you. If there are any questions in the chat, I think Thomas will answer them. By the way, I've seen that the number of participants have gone up since the beginning, so that's always good news. We don't lose participants, we gain participants. Anyone has a question? Thomas made an observation that thinking of REDA is like a graph spreadsheet, where elements are nodes in a graph, and we have constraints, DCR constraints, between the elements as a visual representation. You want to add something to that, Thomas?
Yeah, I just wanted to add this picture that so the basic idea is that instead of specifying control flow separately from data, we take inspiration from the spreadsheet computation model, where we have data and we also have control by expressions that are re-evaluated when their inputs change. So this is now generalized. So instead of only having data in a spreadsheet where you address elements by their coordinates, we now have a graph database, and you can specify reactive constraints between the elements, just using the DCR constraints, which are similar to declare. And then you have input events are like the fields where you type in your spreadsheet, and you have computation events that are the expression events. But the generalization here is that you you can then query the entire graph instead of pointing to a specific coordinate in the spreadsheet. You can use a graph query language, and you can use the Neo4j mechanisms to run this live. And we have an implementation that could have been demoed if Joao was here, but I will not be able to do it, where you can actually see live how this graph changes when it computes.
Okay, nice. Any other questions?
If I might, oh, sorry, I should raise the hand. No.
Yeah.
So,
I saw you raising your hand.
Thank you. Good. Just wanted to ask if there are any insights from a, let's say, performance perspective. So how did you go with memory consumption, especially for the translation and the query answering?
We don't hear you.
Thomas, you seem to be muted.
That's probably a question for Leandro, if he's here.
Yeah, I am. Hello. We haven't tested the performance in depth. We have tried gradually increasing the nodes and the trigger on the database. We went from 10 nodes and 1 trigger to 10,000 nodes, I suppose, and circa 10, 11 triggers. And the increase in time is almost not noticeable. So we do believe it's not, it will not be a problem. We don't have studies in depth of performance yet. I hope I answered your question.
Right. Well, it was just out of curiosity. So basically, the experiments are ongoing, but still, well, 10,000 nodes. It's a good evidence that it's scaling well this far.
We hope so. Yes.
A benefit of the DCR constraints are that they are evaluated locally, so we don't need to generate something that grows exponentially.
Yes.
But we need to test it more.
Looking forward to it. Thanks.
Okay, looks good. I don't see any more questions. So I suppose this means that it's time to round up the workshop. Thank you for these presentations. I would say thank you, audience, for keeping up till the end. And Søren has a final slide here. We hope to see you next year, assuming that the workshop will go on. I think so. And I think we hope to see you in real life instead of virtually. Even it worked well, it's still more interesting or more nicer to do this in real life, probably. Do we have any idea already where next year will be?
I'm sure it'll be revealed shortly.
Okay.
But let me add to that there almost certainly will be a DEC2H next year. We think that the topic of declarative modeling, specifically with decision notations, and as we saw today, data, remains important and understudied topics that is deserving of our attention. So I hope to see you all next year for the workshop again. And thank you for a very nice round of presentations.
Okay, thank you. And thank you all. I think we can close down here, unless one of the other organizers has something to add. No? Then I would say applaud for all the speakers and enjoy the conference. Bye.
Bye. Thank you.
Bye, guys. Thanks.
Bye, guys.